Good evening, students. I'm Dr. Shalini Hanok, Associate Professor, Department of Electronics and Communication Engineering, ATME College of Engineering, Mysore. Today, I'll be discussing few experiments related to basic electronics using virtual lab. The nodal center for ATME College of Engineering is NITK, Surathkal. So, today I will be discussing the experiment BJT input-output characteristics for common base mode. So this has been explained to you in theory about common base configuration and how the working of the common base configuration. I'll just brief you out little bit before starting off with the experiment. These two are the circuits for measuring input output characteristics for common base configuration. So here we have the transistor wherein the base is made common to emitter and collector, and this the input end has the measurements of VBE, base emitter voltage, and IE, that is emitter voltage. At the output end we have VCB voltage, which is connected here, and IC current. So in input characteristics we keep VCB constant. Here VCB is kept constant, and we are going to vary VBE voltage and measure and take down the readings of IE, that is emitter current. So as we keep VCB constant at each level and vary VBE, the IE currents increases gradually. That graph is shown here. So when we keep VCB constant at every constant level, the current IE current increases as we increase VBE voltage at one point, that is called as new voltage. So it remains constant till that point and then it starts increasing. So this is the graph for different VCB we are going to get for input characteristics. This is the input characteristics of common base configuration BJT. So this is the circuit diagram for output characteristics of common base configuration BJT. So here the same diagram, but we are going to measure the output characteristics. So we are going to keep VE, that is emitter current, constant using the voltage VBE, and take down the readings for VCB and IC, corresponding IC current. So as we keep IE at every level of IE current, we will be getting VCB at different levels and currents at different levels. This is the output characteristics which we will be getting for common base configuration. So here we can observe that as and when for different values of IE current and when we vary common base voltage, we will be getting this graph for at each level wherein slightly there is an increase. This increase area is called as active region, and before the active region there is a region where there is no increase, there is a continuous saturation current, that is cutoff region where there is no flow of current. So as we increase VCB, there is an increase, slight increase in IA, and then finally it becomes constant and it goes to saturation level. So for each IE we will be getting this graph. This is the output characteristics of common base configuration. So this we are going to see in virtual lab. So as I have discussed in my previous videos, so what is virtual lab and the introduction related to this. We are going for basic electronics lab, which is provided by IIT Kharagpur, and we have these are the list of experiments which are available. So since we are studying BJT common base characteristics, we will go there, and here are the theory materials available for each thing. Then we have simulation experiments. First we are going to see BJT input characteristics. This is the diagram. Here is the graph plot where we'll be getting the graph. Now according to the theory explained, we have to keep for input characteristics VCB as constant. Here is a VCB. VCB can be kept constant using the rheostat RH2. So that is the instruction given here. We have instruction here. Initially set rheostat RH1 to 1 ohms and rheostat RH2 to 1 ohm. So here is the control for rheostat. I am setting rheostat RH1 to 1 ohm and RH2 to 1 ohm. So after setting RH2 to 1 ohm, our VCB voltage became 0.1 here. So now next step is we have to set the common base voltage to 1 volt by adjusting rheostat. Okay. So second step, we have to set this VCB to 1 volts by setting the RH2. So we'll increase RH2 and we can observe here gradually VCB is increasing. We'll put it to 1 volt. Okay. At 10 ohms of our RH2 we are getting VCB as 1 ohm. So now next is now we are going to tabulate the VBE and take down the reading of IE. Okay. So now VBE can be controlled by using the rheostat RH2. So now we will go for varying different voltages of VEB and then add to table so that that particular 7 ohms for 7 ohms rheostat. So this is the value of VBE. For that value of VBE, how much is the current measure, that is given here also in diagram, and that we are going to tabulate it. So similarly we will tabulate for different values of RH1, that is VBE for different values. Here is the plot. You can observe from the table that gradually the values are getting increased. So we will take some values so that our plot comes little clearly. So it is going on increasing. The current is increasing gradually as we increase VBE. Now we are going to click on plot value. So now we can see, observe this. Since I have taken many values here, so it is not increasing here, but it is increasing at some gradually. This is the plot for input characters. Similarly, we are going to see the output characteristics. For that, we have to select basic electronics. We are list of experiments. Go for BJT common base characteristics and simulation BJT output characteristics. Here in output characteristics we have to keep IE constant. Okay, we will see the instruction here. Initially set RH1 to 1, so that is common for both 1, and we are going to keep 1 and 1 for RH1 and RH2. Then next is set emitter current 1 milliamps by adjusting the rheostat. So we'll adjust rheostat and we'll keep the IE as 1 milli. So let me keep it as 1 milli. Okay, now it is set to 1 milli. Now we have to vary RH2 and increase VCB. So that is what is given in the step number 3. So VCB can be increased by varying RH2. So now the same procedure will increase as see, now we can see RC and VCB values getting increased. So now we will increase here and tabulate the value, increase, tabulate the value, increase, tabulate the value. So this is how we will be getting the values here. Now we can observe from the graph that after 1 milliamps there is almost constant value. The values are varying in 0.01. So almost it is constant. See, at 11th and 12th serial number we are getting constant values, almost constant values. Okay, so when you plot this, so we are getting the ideal graph, almost ideal graph. That is, it will increase. This is the active region where it is having an increase. So after this, there is a constant. For this we can do for different readings of stages of our IE value. So this is a practical observation of the theory what we studied for common base input output characteristics. Thank you.